Imagine waking up tomorrow and discovering that the world around you doesn't fully exist until you look at it. Right now, reality itself might depend on observation. For centuries, science operated on a simple assumption. The universe worked like a giant machine, predictable, solid, objective. A rock was a rock, and a star was a star, whether anyone was there to witness them or not. Then, in the early 1900s, physicists began studying particles smaller than atoms. They expected to find tiny versions of normal objects. Instead, they found a realm where matter appeared completely undefined. You might have heard the internet version of this discovery, the claim that quantum mechanics proves humans can manifest reality with their thoughts alone, or that your consciousness magically creates the physical world. The actual science says nothing of the sort, but the physical truth is still deeply unsettling. To understand what is actually happening, we have to look at the exact experiment that broke our understanding of physics. Once we strip away the mystical interpretations, we're left with a massive anomaly, one that forces us to question our physical relationship with the matter all around us. This illustrates the double slit experiment. Particles fired through two openings should create two distinct clusters on the screen. Instead, they hit in a scattered layout, forming a wave interference pattern. Strangely, even individual particles expand like waves, traveling through both slits simultaneously. Physicists call this state superposition. Before hitting the screen, the electron lacks a fixed singular location. It exists as a vast cloud of overlapping possibilities. A single test dismantled the idea that matter exists in a definite fixed state before we measure it. Scientists tried something simple to solve the mystery, placing a measuring device at the slits to observe the electron's path. Instantly, the interference pattern disappeared. Measured electrons stopped acting like waves and behaved like normal, predictable particles again. The mere act of looking forced a physical outcome. By measuring the system, the universe abandoned multiple overlapping possibilities and locked into a single outcome. This probabilistic behavior disturbed the greatest minds in science. Albert Einstein resisted it entirely, famously insisting the universe doesn't rely on random chance. But decades of tests confirmed the results, which forces us to clearly define what an observer actually is. The universe does not wait for a human brain or a pair of eyes to lock reality into place. In quantum mechanics, an observation is any physical interaction: a detector measuring a path, a photon bouncing off a surface, or a collision with another atom. Reality at its fundamental level isn't controlled by human minds. Rather, the constant physical exchange of information between particles is what collapses infinite possibilities into a definite state. Think about your everyday experience. You see colors, hear sounds, and feel textures. It all feels direct and objective, but your brain is actually constructing an internal model of reality entirely from electrical signals. Beneath that constructed layer of human-sized experience lies a quantum foundation where matter exists as probabilities. Uncertainty is built directly into the fabric of the cosmos. For most of human history, we imagined ourselves as a passive audience sitting outside a finished clockwork machine. Quantum physics suggests a different relationship. Because we are made of matter that constantly interacts with other matter, we are active participants. Our physical presence and the interactions we make force reality to unfold. Even today, modern physics remains divided. Competing theories offer different explanations, but none have fully mapped the precise boundary between possibility and reality. The next time you look around your room, consider what happens when you leave. What is the state of your surroundings with no physical interaction? Certainty is a fragile illusion. If you enjoyed exploring these strange ideas, consider subscribing. And if this topic caught your attention, you'll want to watch our next video, exploring how time itself might just be an